Good day, everyone, and welcome to the International Conference on Human Mobility and Climate Action. Before we begin, we just have a few reminders. Kindly ensure that your audio is on mute while our experts are discussing. You are free to turn on your videos if you choose to do so. We will also be having a question and answer session after the discussion. This parallel session is brought to you by our official conference partner, CIFAL Shanghai. For this parallel session, we will discuss e-governance and urban planning for smart cities. Our first expert for this session is Dr. Patrick Dai. Dr. Patrick Dai currently works as a general manager for the Nanning Good Fortune Heavy Industry Incorporated. He previously worked as a deputy director for the informatization office of Nanning Municipal Government Solution Architect in Shanghai. He finished his PhD in physics from the Tufts University and a master's in computer science from the same university. Dr. Patrick Dai will be delivering a pre-recorded message. And for questions related to his discussion, we will be sending you the link for our bulletin board. All questions posted here will be shared with Dr. Patrick for his reference.
Hello, everyone. My name is Patrick Dai. It is my pleasure to have this opportunity to share with you how China has been using smart city technologies to improve the environment in the last decade, and at the same time, maintain high-speed economic growth and rapid urbanization. Today's report consists of 5 sections. In the first section, we talk about China encountered environment challenges during rapid urbanization in the last 4 decades. The second section talks about environment turning point in 2012. From that year on, China is continuously decreased amount of the pollutions. In the third section, I would like to introduce the concept of smart city and contribute the environment turning point in 2012 to the wider adoption of smart city technologies. Then, in the fourth section, we will talk about how China used smart city technologies in combat with the environment challenges. And finally, some conclusions drawn from this report. Let's first talk about China's rapid urbanization and environment change because of urbanization and industrialization. Since China's reform and opening up in 1978, China began its rapid industrialization, which generated huge job opportunities in cities. More and more people moved from the rural area to cities to looking for better job, better education, and better living standards. Over the last 4 decades, China's population has grown from 960 million to in 1978 to more than 1.4 billion in 2020. During the same period, China's urbanization rate increased from 18% to nearly 64%. Simply speaking, in the last 40 years, China's urbanization rate has been increasing at a speed of more than 1% per year. The number of people living in the cities has grown from 170 million to nearly 900 million in the last year. It is a 4-time increase. In the last 40 years, After rapid urbanization, China cities' annual domestic wastewater discharge has increased from 15 billion to 50 billion cubic meters. This is more than tripled. During the same period, annual household garbage for disposal has increased from 25 million to more than 200 million tons. That is an increase of 7 times. Pollutions are constantly generated, not only in urban households, but also in industries, in agriculture, and in transportation. Industries are the main source of pollution. After year 2000, the heavy and chemical industries in China went through a period of rapid development. Steel and oil industries become backbone of China's economy. On the one hand, this accelerated China's economic growth, but at the same time, the environment degradation became even more worse. China began to face a huge number of environment challenges, such as water pollution, air pollution, solid waste pollution, acid rain, and much more. Although in the first 3 decades of the development, the pollutions were getting worse with each passing day. But fortunately and miraculously, in year 2012 came China's environment turning point. The graph shows economic growth and pollution status in the last 4 decades. The gray bar refers to China's GDP from 1978 to 2016. The red line represents economic growth index, which is calculated on the basis of the GDP and other economic indicators. It is used to illustrate China's economic development. The green line represents Integrated Environment Index, an indicator of China's annual environment pollution status. The index is calculated on the basis of wastewater, waste gas, waste, solid waste, and carbon dioxide emissions in each year. In the first 3 decades of China's reform and growth, environment pollutions increased with the growth of the economy. However, in the last decade, from 2012, although China's economic growth continues, but the environmental pollution peaked in 2011, and from 2012 on, environmental pollutions began to decrease. As shown in these 2 graphs, from year 2011 to 2017, the annual emission of sulfur dioxide and NOx in China shows steady and fast decrease. In just 6 years, the emission of sulfur dioxide and NOx dropped more than 50%. In fact, according to government survey report, all the major environment pollutants have been decreasing since 2012. But of course, with only 2 exceptions. Annual solid waste is still increasing mildly, but with the strengthening effort on the recycling, we expect that annual solid waste discharge will begin to drop soon. Annual carbon dioxide emission is still increasing, and that is expected to reach the peak in 2030 because China's energy supply is heavily dependent on fossil fuels. It takes time and investments to shift our energy from existing energy structure to green energies, such as hydraulic power, solar power, wind power, and nuclear power. Chinese government began to address the environment pollutions earlier than most of us have thought. As early as 1973, the State Council started the war against pollutions, and in 1979, the state legislative body enacted the China's first environmental protection law. The most important measure is the establishment of the rule of three simultaneousness. For the industrial projects, the construction of production facilities, and the construction of complementary environmental protection facilities must design simultaneously, construct simultaneously, and go into production simultaneously. The rule of three simultaneousness was carried out very well by both governments and enterprises. But there's one crucial piece was missing. Enterprises were reluctant to daily operate the production facilities and the environmental facilities simultaneously, simply because the running cost of the environmental facilities was too high. Without operation, environmental protection facilities are only good for showing. That is exactly what had happened. For enterprises, high running cost of environmental protection facilities was formidable. For example, in year 2010, average net profit for manufacturing industries is only 6%. For pollution-intensive industries, such as thermal power plants and steel mills, the situation was even worse. In coal-fired power plants, the heavy coal consumption resulted in huge emission of sulfur dioxide and NOx. Running cost of the environmental protection facility was 6.5% of electricity cost. But at the same time, the net profit from the sales of electricity is only 2 to 3%. In steel industries, the running cost is 3.1% and the net profit is only 3.5%. Local governments had no incentive to strictly enforce environment standards and regulations because GDP was the most important indicator they care about. At the same time, local governments did not possess the manpower and the technological gadgets to enforce environmental regulations. Central government agencies did not have the means to quantitatively assess local government's performance in environment protection. Unfortunately, for over 3 decades, the Chinese government has not found effective ways to solve above-mentioned problems. Fortunately, since 2010, we have found technological gadgets to help the government to combat with the pollutions in China. This is the smart city technologies. Smart city technologies make full use of information and communication technologies to collect and share data about city operations and provide improved city management and deliver better city services. Smart cities focus on data of the cities, including acquisition, integration, analysis, and application of the data from city infrastructures such as transportation, utility, and the environment. Smart city technologies are used to improve the public services, quality of life, economic development, and environmental sustainability. Smart city technologies can be divided into 4 layers. In this diagram, from bottom to up, we have the sensor layer, network layer, platform layer, and application layer. Sensors in sensor layer is used to collect environment data such as traffic flow, water flow, surveillance video, and air quality. Networks in network layer is used to transmit data acquired in sensors to cloud storage in platform layer using mobile network and internet. Platform layer provide data storage, data processing, data analysis, data interpretation, and data visualization services. And finally, in the application layer, the information gained from data are used to create smart city applications to help the government to run the city more efficiently and more wisely. These kind of applications including smart transportation, smart medical service, smart environment, and smart government services. In 2010, Ministry of Environment Protection began to promote the installation of environment sensor networks in the cities nationwide. In 2011, Ministry began the construction of National Environment Monitoring Network. It is used to link all the environment sensors in China together. The ministry also launched environment satellites to improve remote sensing capability to monitor overall pollutions in China in the sky above. The ministry also actively promotes the information sharing in environment protection and utilize the shared data to conduct the pollution source monitoring, environment monitoring, and dangerous chemical transportation checking. This is sensor network map for PM 2.5 installed in Beijing, China. With the continuous development of smart cities around the country, more and more sensors for environment protection would be installed in China in the coming years. Because of the wide installation of sensor networks across China, it is possible for us to have the real-time map of China's environmental status. For example, this is an air quality index map in China, taken 1 week ago. All cities in China are represented by color points on the map. Green means good air quality, red means poor air quality. And it is obvious that most of the cities in China at that particular time had excellent air quality. Now, let's take a look at how smart city technologies have been doing in the combat with pollution in China. For the central government, now it possesses the comprehensive environment data of the whole country and have the ability to quantitatively assess local government's performance on environment protection. Based on assessment, the central government even established one-vote veto system for environment protection. For local governments, they began to put environment protection in high priority. With real-time monitoring capability in hands, local governments have the ability to enforce all environmental standards and regulations strictly. For enterprises, because of the real-time sensors over their environmental facilities and emission sites, they have no choice but to ensure continuous operation of environment protection facilities. The good news is that because all manufacturers are under the same environment inspection, the environmental costs are fair to every enterprises. For citizens, now they have real-time access to environment data over the internet. With the increased awareness of environmental protection, citizens began to get actively involved in the environment protection. If there's any environmental violation around them, they can report the case to proper agencies using social media or by the phone or on the web. The Chinese government has conducted first and second national survey on the pollution sources in 2007 and 2017. The survey is conducted in 4 categories: industrial pollution source, urban domestic pollution source, agricultural pollution source, and mobility pollution source. The comparison of survey results shows big reduction in nearly all key areas of pollutions. This proves that the environment turning point in 2012 is real. These 2 images shows the changes of sulfur dioxide concentration in year 2007 and year 2017 in China. The red color means high concentration, and the green color means low concentration. It is obvious that the sulfur dioxide concentration has been decreased dramatically during the 10-year period. These 2 images shows the changes of PM 2.5 concentration in year 2007 and year 2017 in China. The red color means high concentration, and blue color means low concentration. It is obvious that the PM 2.5 concentration has been decreased over the 10-year period. Now let's summarize today's report. Smart city technologies has helped China to reach the environment turning point in 2012. Smart city technologies has been helping China to monitor and control pollution nationwide, to mandate industries to minimize the pollution, to improve social awareness of environment pollution, to facilitate the public participation of the war against pollution. Thank you, everyone, for the participation. Goodbye.
Thank you, Dr. Patrick, for sharing with us which smart technologies your country has been implementing to ensure an improved society during the urbanization. Our second speaker for this session is Mr. Dong Hanxi, the Product Manager for Shanghai Donghao Lansheng Information Technology Company Limited. He focuses on introducing products and services to various customers. Mr. Dong has translated important documents such as the Normal Management Guide for Science and Technology, Epidemic Prevention of Commercial Buildings, and the Appraisal Index System of Smart Building 3.0. Now, let us listen to Mr. Dong Han-si as he delivers his discussion on limited space and unlimited value. Sir, you have the floor.
Okay. Dr. Patrick has mainly talked about the pollutions. Now I want to talk that the smart cities can bring you convenience. So the name of our product. Let me start. Okay. The name of our product is iProperty. Our goal is to create an all-round keeper for smart building. We want to create more value and respond to Shanghai's call of city digital transformation. Our slogan is limited space, unlimited value. And this is also my topic today. Our company was established in 2019. Although we're a new company, by 2021, we have got the title of Shanghai High-Tech Enterprise. We have also got some software copyright. Our product map is like a butterfly with one axis and two wings. The core part is the data center platform. Based on this platform, we have developed various products. The products can work together in collaboration with the data from the same center, which turns a common building into a smart building. The two wings above, the one on the left is space management. It integrates business, finance, and management. More than 200 buildings in Shanghai are using this system. On the right side, based on SaaS, we call it borderless services. We innovate both independently and integratedly. Working with our partners, our software can work with the hardware to provide more value-added services. We participate in making some important standards. Among them, the Appraisal Index System of Smart Buildings 3.0 is a standard that we made together with Shanghai Institute for Science and Technology of Buildings. This standard appraises the building from these 4 dimensions, including intelligent integration of automation, modern property management, green building, and to be a part of smart city. And we have these corresponding solutions. Next, I would like to introduce our products in these dimensions. The first part is Kepler, the digital twins. We want to make building breathe and think so that it becomes sensible, visible, and controllable. Here are some screenshots of our Kepler interface. The property of Lanshan building is using this system every day. There are 3 columns. On the top of the left, we can see a number, 0, which means all the tasks in the whole building have been completed. These events come from various systems of the building. All the applications are working together based on our data center platform, collaborating with each other. We can see all the tasks have been or not have been solved here. The data on the right side includes environment data, the number of cars, monitors, electricity fee, and so on. The most important part is in the middle. It is the digital space, which is the core part of the digital twins. This is a building information model, or BIM. We used to use BIM in construction, but now we can use it in daily management. The digital space synchronized with the real space. Whatever happened in a building, we can see it in the virtual space. We can go to any floor to see what's happening. Each camera has a unique code by which it is easy to find its physical position in the building. We can also check the devices. We can see the information of the device. All the data is from the sensors. We can also check the firefighting equipment. When there is a fire, it can be detected by our sensors, and the sensors will give alarm to the related persons. Once the workers see the alarm on the digital platform, they can view the scenes through the camera and also check the information of the nearby firefighting equipment. Then it is the pipelines. The model can be easily updated. If the pipelines are renovated, the property just needs to collect the latest CAD drawings and import them into the system. And then the system will update the model by itself. Besides this angle, we can also go into this 3D space. We can ramble in the virtual space. During the ramble, we can also click on the camera to watch the image of the real space. We can also hide the walls to check the pipelines. The next one, our energy product. We call it Awakening Power. Entering the energy interface, the whole blue building is now colored. The color of each floor represents its energy consumption. Red color means higher energy consumption. We can also view the electricity consumption of each floor. In the past, we only knew how much electricity we spend a month. We never knew how much electricity we spend a day, how much electricity we spend up to now today. With these new technologies, we're able to refine our management. This shows our data modeling capability. We have hierarchical structure of all the meters in the building. We also have Sankey diagrams of energy consumption. With more details, our AI can learn more quickly. The previous BA system usually used the PLC, Programmable Logic Controller. Our product used the DDC, Direct Digital Control, and the controller is developed by ourselves. We also use the MQTT Petrol to realize second-level awareness communication. With the data we have, we can forecast the energy consumption of each devices. If the line suddenly goes up or down or suddenly becomes 0, it means that there is something abnormal. And when this happens, the system can tell the property, tell them which room, which floor, which equipment near which meter has gone wrong. And this is the interface of Lanshan Building's command center. Here you can see the data of the chillers, pipelines, and water. The data of our system is changing every second. And there is a lot of data that cannot be seen in a previous system. In the past, the cooling capacity of chiller is very difficult to calculate. Through our system, we can get exact number. The load, COP, power can also be shown. This is data that the property have never seen before, but the data can really help them manage their energy system. In the past, the workers just start and stop the chillers every day, which wasted a lot of power. Now, our AI can convert the frequency of the chillers in time based on temperature, humidity, and personal density. All the real-time data can be read by the property. By using our system, we can increase the overall equipment life and management efficiency. It can also reduce labor cost. More importantly, we can save about 30% of energy, which is a response to the policy that Shanghai will peak carbon emissions in 2025 and realize zero emissions in 2050. The next part is comprehensive security. Security is not a single point. It is a complete system with comprehensive perception, protective alarm, and closed loop management. It includes video surveillance by AI, equipment security, building structure security, fire security, elevator security, personnel security, and security inspection. For example, in video analyzing, we have video condensing and path tracking. Video condensing means that 11-hour video can be condensed to a 90-minute one. We omit the still frames and just show the image that something moves in it. The guards can easily retrieve the full video before and after the key time point by clicking on the key person. The system can also figure out the same person at different time point in different videos. This is the path tracking, so that the guards can find his track with a single photo shot by a single camera. With these technologies, looking for key events is no longer time-consuming or cumbersome, which significantly improve the efficiency of event retrieval. Another one, for example, is fire security. Our fire alarming system can be docked with government's platform. With AI, our monitors can recognize not only fire, but also smoke, which can give warnings much earlier than the smoke sensors. Once the monitor finds smoke, warnings will be sent to the guards. The guards can see the real-time image and find whether it is really a fire or it is just a mistake. If it is really a fire, the windows nearby can be opened remotely. Besides, temperature sensors and smoke sensors can also find a fire. The message will be sent to the fire station. The next one is e-passcode. The code is not only a passcode. It is also a consumption code and a health code in the building. By checking one's code, the machine can get both his health status and his identity. At the same time, the machine can get his temperature measured. Since the information of each person is recorded, all the facilities in the building can recognize us by checking our code. We can use the code to reserve meeting rooms. We can use the code to reserve parking lots, which is more convenient. The code also has a consumption function, with which we can buy things in the stores in the building. We also make an applet, which includes the canteen and various companies in the building. The tenants can display their company's products and or service online, and users can place orders online, and they can also pick up goods offline. We are creating a new ecosystem in the building and bring convenience to the tenants, thus improving the occupancy rate of the building. The next part is digital property. In the past, if a facility went wrong, it could only be found by people. But now, sensors and cameras can also give warnings. Once a facility goes wrong, the message will be shown on the platform, and a task will be sent to the related workers. The time of the whole repair process can be reduced from 5 to 6 hours to only 15 minutes. Public health. How to ensure clean air and clean water. We can give you a real-time data of harmful gases, and it is linked to the robots and window control system to guarantee the air quality and water quality. Once the sensor finds harmful gases, the windows nearby would open automatically, and the robots will go there for disinfection. The environment security is not only visible, but also controllable. We have air sterilizing, surface sterilizing, fresh air system, window control, air filter sterilizing, and sterilizing by robot and drone patrolling. The system is linked with other systems through the data center platform. With all the products above, we want to bring convenience to managers, properties, and all the tenants in the building. Bring you comfortable environment, convenient life, smart experience, considerable service, and safety and security. With the limited space we have, we want to create as much value as we can. So it limits space, unlimited value. Thanks for your time. Thanks.
Thank you, Mr. Dong, for a very detailed discussion. Hopefully our participants now have a better grasp of the idea of a limited space with unlimited value. Now, let's open the floor up for the question and answer session. You may use the Zoom chat to send in your questions or raise your hand and wait to be recognized by the moderator before turning your audio on. Again, all questions for Dr. Patrick will be shared with him after the session. So just kindly go over to our bulletin board for any questions related to Dr. Patrick's discussion. And for this particular session of the question and answer, we will open the floor for questions related to Mr. Dong's recently concluded discussion. So if anyone has any questions, you can send them through the Zoom chat. We have one here, sir. These smart cities technologies collect large volume of personal information. How do we ensure delicate balance between the right to privacy and the use of information to deliver basic services or create value? Sir Dong? Sir Dong?
Well, let's take an example. The example is if you went to a building and you may give information to the guards, and you mean that the guards may gather information, gather personal information. The guards will get the personal information, but nothing in detail. Maybe it's your name and your health code, your phone number. It is. We don't need much details. And the health status in China, we also give it to the government. So nobody will care that. Care this. I'm sorry.
Okay, next, we have another question. I'm wondering how such systems address data privacy concerns. So it's a little related to the initial question earlier.
We have a private patrol in the DDC, in our DDC. So the information will not be gathered by the other people. Yes. There is a secret patrolling in DDC.
So there is a system wherein the information is also filtered, whoever gets access to this.
Yes.
We have another question sent to the CIFAL team. So for countries or areas who are just beginning to discover their digital identity, how do you suggest they manage their digital space, especially in monitoring and providing service for the people?
I'm sorry?
How do you have any suggestions on how countries who are just starting out should manage their digital space?
We have the digital space is very an easy thing for the guards to manage. We don't need much knowledge on computers or on information or on patrols. All the guards can easily manage this space, the digital space.
Here we have, thanks for your outstanding presentation, Mr. Dong. What is your plan on expanding this to other areas?
Now this system has been used in about, I think, about 50 places in Shanghai, and also one place in Beijing, one place in Jiangsu. So now we just want to expand our service. I mean, in China, or we have also expanded the service in International Trade Center, where a lot of Japanese people work in it. So maybe we can also expand our service to overseas.
We also have another question. How much is the spending budget if they are to put up such a system? Do we have like do you have a specific budget or around a range when putting up such a system that focuses on the digital space and other formats?
Now we just focus on things in China. I mean, just focusing on things in China.
So it was mentioned earlier in your discussion that your system also focuses on environment and
environment. Yes.
So how do you suggest smart cities assure that their progression is in accordance with environmental governance and urban resilience? So are there any systems that ensure that with the evolution of these technologies, that environment is still closely managed and also secured?
We manage the environment, I mean, in buildings. For example, if the environment outside is worse, so we can close window remotely, and if the air in the building is worse, we can open the window and also use the robots to make the air clean. We just focus on the environment in the building up to now.
Also another question from our participants. Based on your current experiences, what considerations must be prioritized in order to create a smart system for cities and communities? If you could give like a list of priorities that you think we should focus on for creation of these smart systems.
First, I mean, it is we are in a progress of digital transformation. So the most important thing is that we need to change the management we used to use, and facing the using the new technologies to manage the environment, the people, the status in the building, especially the commercial building.
So thank you for that. Do any of our participants have further questions? Those sent to us previously via chat, or we've all went through them. So last call for questions. Okay, so again, we would like to thank Sir Dong and Dr. Patrick for their insights regarding our topic.
Mr. Nestor is raising his hand,
Oh,
so I think
apologies. Go ahead, sir. Sir Nestor.
Yeah, hi.
Yes.
All right, thanks for the acknowledgement. I have a fairly somewhat complicated question to ask that I couldn't quite phrase in the chat. First off, no, thank you, Mr. Dong, for that very comprehensive and I should say exciting presentation. I'm Kiboy, a grad student with the UP School of Urban and Regional Planning, and also with the Department of Transportation. And really, I'm also working with projects that involve digitization of government government processes. And offhand, I was thinking that coming off from that presentation, really it seems that digitization of these processes will require a huge amount of capital. No? It's clear that a huge investment is required to go towards this direction. And so I was thinking, without delving into anything proprietary, I was wondering if what your insights are, regarding what might help that transition. Digitalization of government services are very much in the public sector. It's a public need driven space, and here we are introducing solutions that are capital intensive. So how do we make? What are your insights on making these two ends meet? How the private sector might sort of connect with the public sector and make these transitions happen?
Let's take the energy product for example. The whole energy system is about 2,000 China yuan. So we can, with this system, we can reduce 30% of energy cost. So maybe for 10 years or for 10 to 20 years, the money is came back. And what's more, with this system and other systems I have just talked about, the people, the tenants live in the building can feel much better, and the occupancy rate of the building may go higher. For the commercial building, the occupancy rate is a very important point for making money. So on one hand, we can reduce the cost of energy, and on the second hand, we can make more money from higher occupancy rate. Maybe in 10 years, we can just get the money back.
I see. So I think that largely largely counts on the economic benefits to private enterprises. Just one last follow-up. No, how about in the capitalization on the information that's gathered from these systems? Do your models currently expect to generate income from the data that your systems generate?
From what?
From the information, for example. I think one of the models currently employed, for example, in the stark example is how companies might be making money off of social media, for example, the information they're able to get from that. Is that model something that can be expected or something to be wary of even with systems like these. Does that question make sense?
I mean, we mainly focused on the commercial buildings. So
Okay.
maybe you have just to talk about the medias and maybe other things. Commercial buildings. When it comes to commercial buildings, we mainly focus on the occupancy rate, and you have just talked about maybe it is a large amount of money. So the whole system I have to talk about is that large amount of money, but maybe a single system is not that expensive.
Understood. Thanks very much. Appreciate your insights.
We don't use the information we get and make money. We don't use that. We don't do that.
So, sir, we have one more question here. How about maintenance? I mean, what if the system stop or becomes broken? Are the maintenance persons or parts available?
Yes, we have 1 year of maintenance, and yes, we have 1 year of maintenance.
All right. Thank you very much, Mr. Dong, for that wonderful discussion. So thank you for participating in this parallel session.